microphone. This here in my hand is a microphone. A microphone. How do I explain a microphone to you? This here is because of this. I'm going to explain what a microphone is, but I'm also trying to paint a picture for you. Whatever I'm saying right now, as I'm talking, as I'm speaking, as I move, every sound I'm producing right now, if this was on, it's going to be imprinted in this. That's why I said this is the most important part, the input. This is the most important part in the sense that this is what's responsible for converting sound waves, what you hear, all those, into electrical signal that will be interpreted by the computer. Without this, we can't have sound in here. This won't pick up any sound to amplify it won't have any analog signal in the first place. A very important part. So there's types. What I'm holding in my hand, there's types of microphones as well. Having defined the microphone. So as I said, a microphone is a device that converts sound waves into electrical signal that can be interpreted by the computer, understood by the computer. That's what a microphone is, acting as a transducer. That is what a microphone is. Now, these microphones, they come in different shapes and sizes and types. And as the shapes and sizes vary, that's how their functions, let me not say sizes, features and types. So this here in my hand is what we call a dynamic microphone. Shure SM58 dynamic microphone. The other name for dynamic microphone, what it's known for is moving coil microphone. That is because it consists of a moving coil. The other name for a dynamic microphone is moving coil. It's known as a moving coil because inside this little thing here, there's a coil, there's a small coil which is attached to the diaphragm, such that when the diaphragm vibrates, this vibration, when the diaphragm vibrates and the vibration is received by the coil, that vibration is converted into electromagnetic signal, which is the vibration in the moving coil is converted into electromagnetic frequency. This electromagnetic frequency vibrating around is converted into it turns into a current, and this current is directly proportional to the sound being received, the sound of the vibration. So I'll explain when I pull out the other kind of microphone why I just went through all that technical detail to see how this one functions. So yeah, that electromagnetic frequency turns into current, which is directly proportional to the sound received, which means the amount of sound is the same as the current produced. So this is a dynamic microphone. With that being said and done, let me just also pull this one out here. Take a look. As far as equipment goes, this school has state-of-the-art equipment. Big ups to the administration for this. Keep this up, and we need actually more. But otherwise, state of the art. So in my hand, I'll just put this down. In my hand, Mr. Cheetah would be upset with me for doing that. Is a Mojave microphone. This type of microphone was there, so that I demonstrate the difference. This, as I said, is a dynamic microphone, and this in my right hand. This in my left is a dynamic. This in my right is a condenser microphone. A condenser microphone. Yeah. Yep. In my right hand is a condenser microphone, and in my left is a dynamic. I ran through explaining dynamic and yeah. So let me just go down to the differences between these two. So mostly the difference between these two is, okay, there's significant differences, the features, the parameters, and also how they work. You see, this is a dynamic microphone, and as I mentioned, the moving coil, but also the other name for this is called a front address microphone. And the reason this is called a front address is because it's only fixed to one pickup pattern, one polar pattern, which is cardioid polar pattern. So which means only this part here, this is what's receiving sound waves, only this part here. Nothing is being received down here, only this part. That's why it's called the front address. Now, the difference, and as I mentioned, the moving coil deal there, so that's why I'm going to the differences between the dynamic and the condenser. This here is a dynamic, and the dynamic microphone has many polar patterns. Some have up to 4 polar patterns, but this one, the Mojave, has 3 polar patterns. These are the pickup patterns. Polar patterns are the ability for a microphone to pick up sound waves. How a microphone picks up a pattern in which a microphone picks up that sound. So here, as you can see, there's a small circle here. This small circle means every part of the microphone all around is picking up sound, and this polar pattern is known as omnidirectional, which means all around, and that's where it's flipped to. So if I flip it in the middle like that, this little love is like a little love. I don't know if you can see it in the middle there, a little heart, is a cardioid polar pattern. The same polar pattern as the dynamic microphone, so which means this is a front address, so which means you can only pick up from this side or this side, not both. That's the cardioid. And if I flip it again, there's a little 8 here, and I don't know if you see that figure, a little 8. This is also a polar pattern known as bidirectional. Bidirectional means if I flip it to the side means I can record, let's say, a duet, 2 people using the same mic. One sound source this side, the other that side. I can flip it upside down like this as I record. One sound wave coming from that side, one from that side. This is what this polar pattern here means. This is what the pickup pattern here means. It means this microphone is picking up, and as you can see, this 8 here, there's the lines here where the lines meet 8 here is this point here, which means there's attenuation here. There's nothing being picked up here. Nothing, only this side and that side. So that's one significant difference between a dynamic and a condenser microphone. The reason I mentioned the moving coil thing is this one comes with the microphone needs phantom power. There's what is known as phantom power. If you remember, coming back to the audio interface here, if you can just bring the camera a bit closer. This button here, this little button here, 48 volts, that is what the phantom power is. Once you turn that on, this is activated. If that isn't turned on, this isn't activated. The difference is the moving coil converts into electromagnetic energy into current, which means it doesn't need a phantom power. It's just directly connected. Remember that difference. It's directly connected. This one needs phantom power. If the phantom power is not on, the condenser microphone is not on. There's more parameters on the condenser microphone. If you bring the camera close, there's this knob here. This knob is a pad, which means a pad means you choose to attenuate a certain decibel amount. You cut off. If let's say if I flip it to 0, which means I'm recording everything being picked up by the microphone here. But if I flip it to -15, it means the microphone is padding or cutting off 15 decibels of whatever is being received. If we come to this one here, this is here. I don't know if I move on a light here. Is it better? This is a filter button. Here is a band pass filter, and this is a low cut filter. If I flip it to this side, it means I'm allowing all frequencies to come through. Every frequencies are coming through. But if I flip it to this side, it means I'm cutting off the low frequencies, the low ends. Yeah. So that about sums it up for our condenser microphone. And by the way, a condenser microphone comes in 2 types. There's a large diaphragm condenser microphone, which is what I have in my hand right now, which has all these features, and a small diaphragm condenser microphone. We actually do have small diaphragm condenser microphones, so let me just demonstrate that. Nice. This AKG C451B. This is a small diaphragm condenser microphone. If we move the camera close, let me move into proper lighting. There's a little heart here, a little heart shape here. There's a little heart shape here. I don't know if you can see it. Let me here. That little heart shape there, that is what I was referring to when I was saying a cardioid polar pattern. So that's another difference between the small diaphragm and the large diaphragm. This one only has one polar pattern, one pickup pattern. There's features here. This one it's got a frequency filter and a pad as well. You're able to reduce the amount of amplitude being received up to -20. If you're able to see here, up to -20. And here are the filters. There's a band pass filter, a low cut filter, and the amount of frequency you're going to cut off here, 75 Hz, 150 Hz, low cut. So which means everything under 150 Hz is being cut off. And here it means everything under 75 Hz is being cut off. And this means line signal. Everything is coming in. This is the output. XLR. We've got an XLR cable. Like that. Nice. So that about sums it up on our studio setup. We even messed up the studio trying to demonstrate a simple thing. So with that said and done, just a recap of what we went through. Always remember, when setting up the studio, first of all, follow the order of powering. The order, yeah. So I'll just go through the order of powering up the equipment so that we just remember. Power supplies, we noted it's needed there. Comes to our power cable. Our power cable, as we noted again, there's only one connection, very convenient to avoid hum and buzz, the whole circuit noise. A lot of circuits, there's a hum and buzz in the circuitry that amps up the noise. From that, the power surge distributor to the audio interface. Our audio interface, speakers and computer connected. So our audio interface, let me just run through. I'm sure some of us, just so that we remember, we went through the parameters of the audio interface here. This here is the monitoring knob. It helps you adjust the amplitude of the monitors so that that's obvious. These are not important for now. We'll come and explain that next time. Here, we've got parameters here. So the audio interface, as I said before, is a device that converts analog signal into digital. Converts analog signal into digital signal using the digital and analog converter. And it also converts digital to analog using the DAC. And this machine here also consists here, if we look here, if we bring camera closer here, it's written preamp. It contains a preamplifier. This means it also amplifies the signal being received from the snake, from the input. The input signal being received is also being amplified here in the audio interface as well. So if we come close here, if it's written here preamp. So there are times when the signal being received from the microphone here, and you're trying to process it, and the signal is not really powerful, as strong as you'd like. So the audio interface comes with a preamplifier, which converts low-level signal into line-level signal, which means good signal, which is good quality for your processing, for your processing and whatnot. So this is also something to remember. And outside here, as you can see, this preamp, it's inside. The preamplifier is inside, and this outside here is a knob. This knob is known as a phase button. No, this is known as a gain knob. Sorry about that. The gain knob. I got carried away. Gain knob, not phase button. This is known as a gain knob. Gain. What gain does? If you increase the level of gain, it means you're increasing the signal level. It means the amount of signal being picked up is, either high or low. Low level signal is not good. Is not good for good quality sound. You need at least moderate level signal or high level signal. That's good for audio processing. So this is what helps you achieve that. And this, by the way, is only relevant before recording. Pre-recording, not post. Pre-recording. That is the only time this knob is applied. You cannot use this knob once you've recorded. Nothing happens. There's what we call signal to noise level. The signal to noise ratio, rather the signal to noise ratio. The amount of signal to noise. Noise is the unwanted sound, the unwanted elements in the audio signal, and the unwanted elements in the audio wave, audio file or sound, and signal is the wanted sound. That's the difference. So the signal and signal to audio level is balanced using this knob, the gain knob, the signal to noise ratio. The only time you can reduce the signal to noise ratio, improve the signal and reduce the noise, is before recording using the gain knob. If you increase the gain here, it means the amount of noise is reduced in your recording and only good quality sound is recorded. However, if this knob is reduced here, you're going to get a lot of noise and poor sound, poor signal, which is, I recommend just re-recording and resetting things properly. So we need to consider the signal to noise ratio before recording. The signal to noise ratio is what helps us establish the headroom. The headroom is the amount of amplitude level left for, the amount of room left for either a signal level to be amped without clipping, without it clipping. That's what headroom is. The how much you can increase the amplitude level of that signal without it clipping. That is what the headroom is. That is what you're controlling with this knob here. So a very important knob as far as signal quality goes. Always remember that. Before recording, adjust the gain knob to ensure the signal to noise ratio is well balanced. Speakers. I think we've mentioned a lot of these, but abandon the speakers. Output. These are the main monitors. This is what the output is. This here, microphone. Let's get the here. This is the input. This is the output. This is where it starts. That is where it ends. That is where sound ends. Sound begins. Sound processing begins at the microphone and ends on the monitors, the speaker. So these monitors or speakers help us monitor the sound we're working on, manipulating or working on, the project we're recording, instruments we're recording. If you want to hear the overall sound, it's output through the speakers. So now these speakers, you don't just place them anywhere. After this, there's going to be a video of us demonstrating how all this can be set up into a proper recording setup. Can you just zoom back a bit so that we demonstrate? Have you seen how these speakers are placed all facing towards me? There's also a reason for that. Yeah, and for those I'm sure who are familiar, they might be asking the question, why are the speakers placed so close to the wall? This is just improv for it being the monitoring room and all that, but this is not the proper setup, proper speaker setup. If you want to set up a listening position, you have to leave provision between the walls and the speaker to reduce on the amount of reflected sound. If the speakers are placed too close towards the wall, you have a lot of reflected sound, which will that will cause inaccurate reading of the. You have inaccuracies when you're trying to determine what is wrong and what is good with the sound because of too much reflected sound. The best sound you need when monitoring is direct sound, not reflected sound. So placing speakers in that fashion here, there's a lot of reflection sound produced. This is just don't set up like this in short. This is just improv for mostly headphones are used in this monitoring room. These are only used when there's actual recording going on, but for monitoring purpose, like serious monitoring, we use headphones here. So don't imitate this setup. This is a very poor setup. As I can see, even the lining is not very correctly put. We're going to demonstrate how to properly set up the listening position. The listening position, I'm sure some of you are wondering, is where I'm seated right now. This is what is known as a listening position, where I am going to sit to monitor the audio being worked on. The listening position is a point where the two speakers converge to give me a clear perception, or rather interpretation, of what I'm listening to. Here, this is so. There's a whole process you follow. We're going to go through that soon. Sure, will be out there. And with that, I think we're about done with the basic equipment you need. And by the way, this is not basic equipment. This is state-of-the-art equipment. Basic equipment, even this isn't basic, but in a basic setup, like for starters, this is a complete audio 2. Sorry about that. A complete audio 2. This is the same as this. The only difference is the features and the amount of channels, input channels, the amount of input channels it can take. That's what differentiates this from this. Otherwise, in a smaller or simpler studio setup, you go for this and that, explaining the same thing I was explaining, but I was just trying to demonstrate that this is state-of-the-art equipment. So yeah, see you next time, guys.